Hey guys, how you going? Just want to run through some congruence practice problems with you. So basically the purpose of this video is going to be to go through some of the revision questions set in the PowerPoint, and these were taken from your math textbook. So the solutions are in that PowerPoint, but this is just to go through. This video might be quite long, so to best kind of use it, just skip ahead to the questions that you want to look at. And you should be using it as a guide, trying it yourself, and then checking back afterwards to see if I can help you through it. Okay, so let's get into this one. I'm just going to pick my blue. All right, so the first, what I've got on the right hand side, and it seems like my face is in the way a bit, just a reminder of the 4 congruency tests. So side, 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 angle, and right angle, hypotenuse, side. So the first question, are the following pairs of triangles congruent? If yes, state the congruence test used, and angles marked with the same symbol have the same value. So let's look at question A. So we have 2 triangles here. Now I can see a side marked with a dash and another side marked with a dash. They're the same length. And then a side marked with 2 dashes and 2 dashes, and the angle that is in between those. Okay, so the internal angle, and that angle is the same for this triangle here. So we can say yes, those triangles are congruent. And it's not saying a full proof, it's saying if yes, state the congruence test used. So the answer is yes, and the congruence rule is SAS, side, angle, side. For B, we've got a right angle, which is in this triangle as well. We have another angle that is the same, indicated by the same dot, and we have a side that is the same, and that side is opposite the angle marked with a dot. So we just need to make sure that's the same on this triangle, and it is. So in this case, these two are congruent, and the proof that we have is the Rhs rule. So right angle, hypotenuse, and a side. Okay. Now, having said that, I realized the mistake that I've made. So I'm going to go back and fix my mistake. So this is why it's not RHS, because the H stands for hypotenuse. And the hypotenuse is the longest side of a triangle, which is opposite the right angle. So the hypotenuse is actually this side here. And we don't have information about that side being the same on the triangles. There's no dash, there's no info. So therefore, we don't have enough information for that proof. But the proof that we do have is an angle, side, angle proof. Okay. So for an angle, side, angle, all right, the side doesn't need to be in between the angles. It's just a corresponding side. And I've already proved that that side is corresponding. So the proof was correct. It was just the wrong test that I wrote down. So it's ASA, angle, side, angle. We'll make sure we get that 100% the next time around. For C, the 2 triangles, they are not congruent because the sides are different. Now, this triangle looks a bit smaller, but it's not about how it looks, it's about what you can see. So it's 1 dash and then 2 dashes. So those triangles are not congruent. For D, we have angles, okay? We have a side, and we have another side that is shared between the 2. So we don't need to have markings on it because that side there is the base of both of those triangles. So we can say they are congruent, and the test that we are using is side, angle, side. Okay? And remember, the angle for a side, angle, side proof needs to be in between the 2 sides. So it's an internal angle. And for E, let's see what we've got here. Now, I think this might be RHS. So we've got a shared side. We've got a side that's the same here. And we've got a right angle. Now, that's going to be an RHS proof because the opposite side of the right angle, which is called the hypotenuse, is a shared side. They're equal to each other. So that's going to be a yes. and my proof is going to be RHS. Awesome. All right, let's move on. So question 2, if triangle ABC is, now that isn't very clear, but it's congruent to, that's the 3 lines. So this sign here means congruent, which is the 3 dashes. So if triangle ABC is congruent to triangle QRS, answer the following questions. And it says you might want to draw the triangles. So I'm just going to draw 2 triangles here. They're not going to be perfect, but that's okay. And ABC, so I'll go A, B, C is congruent to QRS. So I need to make sure that because they're annotated that way, and I went left, top, right. For QRS, I'd be going left, top, right. Just making sure that's the same. Okay, so part A, which angle is included by the sides AB and BC? So the side AB is here and BC is here. So the included angle would be the one in between those. So that's going to be angle ABC. Okay. So usually it could be angle CBA as well. I would just go ABC because that's the correct way to say it in terms of the alphabet, I guess. Which side is included by triangle SQR, change color, and RSQ in triangle QRS? So if you just read that, it's kind of like what? But if you draw it, it's a lot easier. So angle SQR is here. So SQR is the middle letter. And angle RSQ is that angle there. So the included side, the side that's in the middle, is this one. So that's going to be QS. Next one. Which angle in triangle QRS must be congruent to angle BCA of triangle ABC? So angle BCA is this one here. So the congruent angle in this triangle is going to be this one here. So the answer is going to be angle at, this symbol is really bad, ABC once again. And oh, sorry, whoops. That is the one, and that's the congruent one. Sorry. So that's going to be QS. I'll get there one day. Okay, angle QSR or angle RSQ. Either is correct. Angle QSR or angle RSQ. And the last one. Which side in triangle ABC is congruent to QR in triangle QRS? So QR is this side here. So the congruent side would be this side here, which is going to be AB. Excellent. Let's keep going. Show that the following pairs of triangles are congruent, stating the congruence test used. So for this one, we are going to simply state the 4 tests, which one is correct. So I might show the full proof, but at the end of the day, all we need is that answer. Okay. So triangle ABC, we have 3 sides and no angles given. So we've got 9, 8, and 16, 9, 9, 8, and 16. So these are congruent because all 3 sides are the same. Okay. So if I was to prove that, I would say AC, which is 8 centimeters, is the same as FE, which is 8 centimeters. So I'll just go AC equals FE. And then I would say AB, which is 9, is equal to DF, which is 9. So AB equals DF. And then the last one, we would say BC equals DE, which is 16. BC equals DE. Okay. So I'll say therefore, 3 dots. That means therefore, triangle ABC is congruent to the 3 dashes, triangle DEF, and the proof or the test is side, 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 because we have 3 sides that are the same. Okay, done and done. Question B, we've got an angle, so 65, which corresponds to this angle here. We've got a 50, which corresponds to this angle here. And in between the 65 and the 50, we have a side of 10. So in between the 50 and the 65, we have a side of 10. Okay, so should I say yes, they're congruent? Yeah, I'm supposed to say that. Okay, so yes. So for B, I'm going to say yes, okay, straight away. And this is our proof that we're going to do. So we're going to say angle GIH, which is this 65, GIH equals angle JKL. Okay, and then we're going to say the side. So is this an I? I'm going to say that's an I and that's a J. I can't read it very well. So I'm going to say angle GIH. Oh, sorry, my bad. IH, which is a side, equals JK, which is a side as well. All right, so that's that 10. And then I'm going to say this angle here, so angle GHI equals this angle here, angle KJL. Okay, so therefore, triangle GIH equals triangle JLK, and the rule is side, angle, side. Okay, we've got a side, we've got an included angle, and we've got a side as well. Done and done. So question C, we've got a side of 3, a side of 5, and a right angle. Now for the RHS rule, we need a right angle at hypotenuse, which is the side opposite the right angle. So the opposite that right angle there is 5, and opposite that right angle is also 5, so that's good. And then another side, which we have 3 and 3. Okay, so these are congruent, which is good. So let's write that proof formally. All right, we can say angle OMN equals angle RQP. Okay, and that equals 90 degrees. That's a right angle. And then we can say the side or the hypotenuse. So we'll say ON is equal to RP. Now, if you say PR, RP, it doesn't matter, right? And then the third proof we say is MO is equal to PQ. And we go, therefore, triangle OMN equals triangle RPQ, and the proof is RHS. Okay, so that's another yes from us. And the last one, okay, so now we've got 2 sides that are the same here, 10 and 10, and then these same 2 sides that are the same here, 10 and 10, and there's an included angle of 40 degrees. Okay, so that is enough proof to say that they're congruent. So that's a big yes from us. So what's the proof? It's going to be side, angle, side. So if we're flipping it, we're going to have to say SU is equal to, now it doesn't matter which one we say, it's going to be the same. So it's going to be equal to XV. And then the included angle, so angle SUT is equal to angle XVW. And then we'll say the 2 sides that we haven't done yet, so TU equals, I said XV before, so it's VW. And therefore, triangle SUT is congruent to triangle XVW, and the rule is side, angle, side. Excellent. Okay, let's keep rolling here. Find 3 pairs of congruent triangles among the following diagrams. Write a congruence statement for each pair and state the congruence test used. Okay, so let's look at this one. So triangle BAC. So we've got a side of 12, a side of 8, and an included angle of 40 in the middle of those two. So we want to find a triangle that has that same information. So let's look for 8 and 12. Okay, I can see 12 and 8 here, and there's an included angle of 40. So those two there are congruent triangles. So I can say triangle ABC is congruent to triangle MNO. And the reason for that is going to be side, angle, side. So the proof is SAS. Okay, so let's look for another triangle pair. How about this one here? So we've got 61 degrees, 72 degrees, and an included side of 15. 61 degrees, 72 degrees, included side of 15. That's enough for me. So triangle PRG is congruent to triangle, so this one and that one is congruent to triangle I can't see that, GIH, I think. GIH. And what's the rule? So we've got an angle, a side, and an angle. So that's the ASA proof. Angle, side, angle. Okay, let's see if these two leftovers are congruent. So we've got 3 sides that are all 10, 3 sides that are all 10. That's enough for me. So triangle DFE is congruent to triangle LFJ. Can't read the letter. JLK. And the proof is SSS. Done and done. All right, which of the following triangles is not congruent to the triangle shown? So we've got 2 angles and we've got a side. So that's an angle, side, angle proof. Okay, so let's check this out. How about A? So we've got 65, 80, and a side of 3. Now, keep in mind the angle is opposite, the side is opposite to the 65. So that's what we're looking for. Opposite to the 65, that's good. So 65, 80, and then the side of 3 is opposite to the 65. That's good. So 65 and 80 and the side opposite to the 65, that should be where the 3 is, not there. So that is not congruent to this triangle here. So 80, 65, opposite, 3, that looks good. Okay, so the answer to question 5 is C, is not congruent. Which test could be used to show that these 2 triangles are congruent? So the trick here is that when people see a right angle, they typically think RHS. And that's what I did in question 2, but that's not the case initially. So opposite the right angle is the hypotenuse, and we don't know that side. We don't know that they're the same. Okay, so it's not RHS. So what is it though? We've got angle, angle, side. Angle, now is that 50, is that the same number? Oh gee, I can barely read that actually. That's really hard. I'm gonna have to assume that's 55. To me that looks like 56. Okay, I've just looked in the book and those 2 numbers are both 55, so we can keep it there. All right, so what's our proof? We've got an angle, and a side. So the proof that could be shown that the 2 triangles are congruent is C, angle, side, angle. So 55, 90, and then a side that's opposite the 55, and that side is opposite that 55. So yes, angle, side, angle is the proof that we're looking at. The last one, for each pair of triangles below, show that they are congruent, stating the relevant congruency test, and state the value of the pronumeral. So this should be interesting. So let's look at A. We've got angles. Okay, so we've got 50 and 75, and we've got an 8, and that 8 is opposite the 50. So the 50 and the 8 is opposite the 50. So basically the relevant information is the 50, the 75, and the 8. So the 9 is useless because there's no 9 on the other side. Okay, so that's an angle, angle, side. So the proof there is angle, side, angle. All right, B. So I should say show that they are congruent state. Yeah, so all you have to do is state the test. So B, we've got a right angle. We don't know the hypotenuse, so it's not going to be RHS. And we've got, so 69, opposite that is 4. So we don't know what that is, so we can't do that. Okay, so it's going to be the side of 4, the angle, which is the right angle, and the side of 3. So side, the right angle, and side. So that's going to be an SAS proof, and they are congruent. I've just realized that the part 2 says state the value of the pronumeral. So let's figure that out. So the pronumeral is for part A, X. So now that we've proved that they're congruent, we just match them up and they're just mirror images of each other. So the X is going to be 9 meters. So X equals 9 meters. For this one here, we proved that they're congruent. This is the pronumeral, and that matches up with the 69 degrees. So that's going to be X equals 69 degrees. So for part C, what have we got? We've got an isosceles triangle. We've got 2 sides. Now that's 6, and that's the same as that, so that's going to be 6 as well. And then here we have a triangle that it's flipped. So we can see the side of 6, and that matches up with the 6 as well. And that 40 degrees is an included angle between those two sides there. So I would be saying side, angle, side, okay, which matches up with this side, this angle, and this side here. So they are congruent, and the reason for that is SAS. Now that we've proved that they're congruent, what's the X pronumeral? So you can see that this triangle is rotated on its side. So this side here corresponds with this side here. So we're going to say X equals 5 centimeters. For part D, we have looks like an RHS proof to me, because opposite the right angle is a 9 and opposite that right angle is a 9. So that's a great start. And then we need another side that's corresponding. So we've got the 7, which matches up with the 7. Okay, so our proof is RHS. And what's the value of our pronumeral? So our pronumeral is H. It is an angle here. Okay, so that angle is opposite the 7. You can kind of draw a line there like that. So 7, the angle opposite that side is 58. So now that I proved that they're congruent, that means that they're identical. So I can say that X is equal to 58. For E, all right, so we have 7, 15, and the included angle is 85. 7, 15, the included angle is 85. So that's a very easy SAS. And therefore, so they're congruent. So the M is opposite to the 7. So the 7 is here. So the opposite angle there is 19. So if they're congruent, I'm going to say X. Actually, it's M, not X. M equals 19. I think I stuffed that up before. That's a H, not an X. Doesn't matter. It does, but it doesn't. All right, last one. All right, lots of stuff going on here. So I see an angle of 85, a side of 8 that's included with another angle of 63. So that's the included side. So 85, 63, and an included side of 8. So that's going to be it. So I'm going to go angle, side, angle is my proof. Okay, angle, side, angle. And The pronumeral, which is Z, is opposite the 8. So 8, or actually it's let's do opposite the angle. It's opposite the 85 degrees. So opposite the 85 degrees is that one there, which is 7. So that matches up with the Z. So Z equals 7 kilometers. Guys, that's a long video. Hopefully it helped you a little bit with some of these questions. Thanks for watching. Stop. Thanks for watching.